Hey guys, I'm not sure you can see that, but that is a sawtooth wave on my oscilloscope. Yeah, maybe now you can. There's glare. Anyway, that's a sawtooth wave, okay? So I'm going to be showing you the generator I use to actually build said really sawtooth wave. Okay? So, it is about 60 microseconds per cycle. Uses that circuit right there. Pretty simple circuit. If the camera falls over, you can see that I need to adjust it. But right here, that transistor is sort of the heart of the circuit. It uses one transistor. It's powered by, it must be powered by at least like 12.5 volts minimum, and the more voltage you go, it just decreases the it increases the frequency. And then this, and it's based, you see that blue capacitor down there, that's a capacitor, that's the main capacitor of the circuit. These two, this resistor, this capacitor and this resistor, are a filter, an RC filter. So it's based on that schematic. And so the way this works is that you have at least 12 volts, 12.5 works. I have a 1.2K resistor here, connected through a 220 nanofarad capacitor to ground. Now this capacitor can be any value you want, and it changes the frequency of the sawtooth wave, so experiment around with it. I then have a transistor hooked up, except the base is not hooked up, and it's hooked up backwards. So in fact, the emitter is hooked up to between the resistor and the capacitor, and the collector is hooked up to ground, so it's backwards, okay? And your signal is going to appear here, but it's going to appear with a DC offset. So I just have it going through a 1 microfarad capacitor and a 1K resistor. This creates a little RC filter here, and then your output would be tapped right there. So this would be out. And that's a sawtooth wave. So that's the circuit. Real simple. You can also tap here if you would like, but it's going to have a DC offset. And it's about 1.5 volts per peak to peak. So, really simple. And the way this works is the resistor charges the capacitor, right? And it charges the capacitor at a set rate. So that is the ramp. If you see a sawtooth wave, you know it looks like this, right? Ramp down, ramp down. So the charging of the capacitor is the ramp, right? Then once it reaches the top, what the transistor does is the transistor actually, this is a 2N3904, but it can really be any NPN you want. It's going to change the amplitude. Because what happens is at the top is that the 2N3904, it actually breaks down on the inside and basically becomes just a conductor. So it reaches its breakdown voltage, I think is what it's called. And then shorts right there to ground. That's the sudden drop you see. Then once it's at ground, once it's short to ground, because now it's at ground, it's not at its breakdown voltage anymore, so it's going to ramp back up again. So different transistors will give you different breakdown voltage, have different breakdown voltages, and that'll give you different amplitudes. So this RC filter here is just to remove the DC offset you're going to find here due to this resistor. Also, it's worth mentioning it's quite a pure sawtooth wave, except the ramp, this is what you would expect, right? A linear ramp and straight down. It's actually going to provide a slightly curved ramp, right? Maybe not that much, but you're going to get a slight curve, right? It's hardly noticeable on my oscilloscope here, but it's going to be curved, and you're going to get about 10% change over linear, so the curve can vary by 10%, usually in this direction, curving up. It doesn't usually curve inwards, it usually curves upwards. But you're going to get about 10%. I'd like to know this circuit is inspired by RadioFun232, so thank you, RadioFun232, for your circuit. And I plan to use this as a time base for an oscilloscope. Then I'm going to make a little crow oscilloscope with one of my CRT TVs for the particle accelerator series that I'm doing. So that's really it. That's your schematic, and it's built up on a breadboard. It's really easy to build. Just make sure you have at least 12. I would cross that out and write 12.5, but experiment, because each transistor is going to be different, but here, where I live, 2 and 3 nanophores are really easy to come by, so I have like 100 of them, so yeah. Thanks for watching.